Let's begin Chapter 4. In your textbook, this includes pages 231 through 234, 236 through 241, and 244 through 245. For Chapter 4, you'll want to complete all of Exploration 4.1 plus Exploration 4.2, just numbers 1 through 19. Since Chapter 4 is a lot of vocab, which you may already be relatively familiar with, I recommend reading the chapter, writing down the vocabulary, then completing the explorations. Use this PowerPoint as a way to highlight and reinforce the vocabulary. In Chapter 4, we'll learn about causation and be able to answer the question, can we say what caused the effect? Here are some big ideas of Chapter 4. Previously, we've looked at research questions focused on one variable, and now we're going to start focusing on research questions comparing two groups. Questions like, are smokers more likely than non-smokers to have lung cancer? Or are children who use nightlights as infants more likely to need glasses than those who didn't use nightlights? In comparing two groups, we see that there are two variables we are recording now, like smoking and lung cancer. So, with these comparisons, we will determine if there is an association between our two variables. Then, determine when we can conclude the outcome of one variable caused the outcome of the other. To have these words defined in your notes. Let's start with the explanatory variable, also called the independent or predictor variable. This variable is what we think is explaining the change in the response variable. Many times, it is the variable the researchers are manipulating. When comparing groups, the explanatory variable will always be the groups we want to compare. So what type of variable then is the explanatory? It must be categorical, since we will be defining groups. The response variable is also called the dependent variable, and it is the variable we think is being impacted or changed by the explanatory. The response variable will always be recorded, regardless of what type of study design is being used. I'll give you a few situations and let you choose which would be the explanatory and which would be the response. Let's say our two variables are smoking and lung cancer. Which will be the explanatory and which will be the response? Smoking likely will help explain if someone gets lung cancer, not the other way around. So smoking should be considered the explanatory and lung cancer the response. How about heart disease and diet? This is a bit trickier. If someone has heart disease, it could certainly impact their diet, but more likely researchers would be interested in if someone's diet determined if they developed heart disease or not. So we would probably consider diet to be the explanatory variable and heart disease the response. How about this last one, hair color and eye color? Any idea on this one? Me neither. It would really depend on the research question. As you can see, sometimes there's a clear distinction between the explanatory and response variables, and sometimes there isn't, and it depends on the research question being asked. Here are some more vocabulary terms. An observational study is when researchers observe individuals and measure variables of interest. Researchers do not assign individuals to a group. Examples of conclusions from observational studies would be a significantly higher proportion of individuals with lung cancer smoked compared to same-age individuals who don't have lung cancer. Or college students who spend more time on Facebook tend to have lower GPAs. In these examples, note that we cannot assign whether someone smokes or not. That would be unethical. So we merely observe the two groups of people. And with the Facebook example, again, we would not assign how often the students were on Facebook. That is just something we would record about the student, making this an observational study. In both of these examples, I explicitly said what we would be assigning, smoking status or time spent on Facebook. Would those be the explanatory or response variable for these situations? They would be the explanatory variable. So specifically in an observational study, the explanatory variable and the response variable are both observed. Nothing is assigned. Then we will look at association. Two variables are said to be associated if the values of one variable provide information or help you predict the values of another variable. We can determine association by looking at conditional proportions or means for one group and seeing if it's different than in the other group. A confounding variable is a variable that is associated with both the explanatory and the response. A couple of key ideas about confounding variables are listed below. They must be measured on the observational unit. They must explain the direction of association between the explanatory and response. Let's use our Facebook example to understand confounding variables more. We noted that college students who spend more time on Facebook tend to have lower GPAs. A potential confounding variable here would be social life. Students who spend more time on Facebook may have a more active social life and therefore study less, which would lower their GPA. I can measure social life on an observational unit, a single college student. It is related to both Facebook usage and GPA, and explains the relationship that higher Facebook usage is associated with lower GPA. Because of this potential confounding variable, I cannot say using Facebook causes a lower GPA among college students on average. It could be their social activity and not their Facebook usage that is lowering their GPA. Confounding variables do not allow us to draw a cause and effect conclusion between an explanatory variable and a response. In an experiment, a researcher will actively create the groups by assigning experimental units to the conditions. An experimental unit is just another name for an observational unit in an experiment. Assigning groups means we always assign the explanatory variable in an experiment. So the explanatory variable will be assigned, the response variable will still simply be observed. Random assignment means each experimental unit has an equal chance to be in any of the experimental groups. Random assignment is the ideal way to form our groups. Why? Complete Exploration 4.2 and check the discussion post to answer that question. Also look through the Chapter 4 Big Ideas PowerPoint to understand random assignment more. Finally, let's discuss blocking. Blocking is when we force groups to be equivalent on a potential confounding variable that is easy to measure. For example, let's say we have a sample of 100 students, 60 of them attend MSU, and 40 are Grizz, and we want to block on school. That means if I'm making two groups, I could randomly assign the 60 MSU students to each group, meaning there would be 30 MSU students in each group, and take the 40 students and randomly assign half to each group, meaning 20 would be in each. That would make each group equivalent to 30 MSU students and 20 students. So the proportion of MSU students is the same between the two groups. Blocking only works on variables you can easily measure and create distinct groups from. It forces your groups to be identical by randomly assigning to groups within each block, rather than randomly assigning from the sample as a whole. In this way, we have forced our groups to be the same on this potential confounding variable, making it not confounding. Finally, let's make sure we understand the difference between random sampling and random assignment. With observational studies, random sampling is often done. This should allow us to make inferences from the sample to the population where the sample was drawn, or allow us to generalize the results from our sample. With experiments, random assignment should be done. This allows us to possibly conclude causation. Random sampling is how we gather people to be in our sample. Random assignment is how we create groups. Note that these are general ideas. Not every observational study uses random sampling. Just the good ones do. And not every experiment uses random assignment. Again, just the well-designed ones. Also note that assignment to groups is a defining feature of experiments, so no observational studies will use random assignment. But we could see an experiment which also used random sampling. Therefore, in any type of study, we should decide both, was random sampling conducted or not, And was random assignment conducted or not? Confounding variables are controlled in experiments due to the random assignment of subjects or experimental units to treatment groups. By randomly assigning people to groups, we tend to balance out all other variables except for the one manipulated by the researcher, the explanatory variable, between our groups. In that way, our groups are similar or equivalent on every variable except for the explanatory. So any change in the response between the two groups must have been caused by the explanatory variable. Thus, we can conclude cause and effect conclusions in an experiment when we have randomly assigned. Through random assignment, we have eliminated all other possible confounding variables, and so any change in the response must have been caused by the explanatory variable. Chapter 4, Scope of Inference. In Chapter 2, we talked about generalizability. If we have a random sample, we can generalize our sample to the population from which the sample was drawn. In a non-random sample, we should ask ourselves, is our sample representative of the population? If we can argue it is representative, then we can generalize the results of our sample to the population. If not, then we can only generalize the results of our sample to some hypothetical population which we don't know, which is similar to the sample. Then, if and only if we are comparing groups, we can determine potential causal relationship between the variables. In a randomized experiment where we have random assignment, we can draw cause and effect conclusions, or we have causal inference. In other words, we can say a change in the response variable is caused by the explanatory. In an observation with no random assignment, confounding variables could be present and could be affecting the response, and therefore we can only say there's an association between the explanatory and response variables.